Hello, this is Mr. White, and this video is on Ugly Algebra Part 1. Our objectives in this video are to continue introducing the concept of the derivative, a calculus topic which presumably we've already discussed a little bit in class. But the real objective here, the main objective, is to become fluent with the algebra that comes up often when working with derivatives. Even in a calculus class, the algebra is often what gets in our way, so we're trying to become better at all the skills that we're supposed to know going into calculus. All right, so here's an example, and we are instructed for the given function, which could be an unnamed function like y or a named function like f of x. And you see here we have a named function f of x. For that given function, fully simplify its given derivative. In other words, either y prime or f prime, as you see here, and that is how we read that symbol, not f apostrophe, but f prime. And find the critical numbers. If you don't know what those are yet, you'll see in context what those are, and or vertical asymptotes. Check by graphing the original function on a calculator, intelligently choosing the window settings, and then tracing to the critical numbers. So we're going to do all that. But first things first, this is not the actual example I'm going to go forward with. This would make a decent example where f of x is the product of two factors here, but I'm going to replace that one with a quotient instead, which will make the math only slightly more difficult. And similarly, I'm going to replace the derivative here. And again, it looks a little more daunting, but if you can handle this example with a quotient, then any exercise you come across with a product should be just fine. All right, so let's get into it. This is our derivative, f prime. And what do we do first? Well, we're going to rely on some old skills here. First of all, we need to identify how many terms there are in the numerator of this expression. So what do you think? How many terms? I hope you're thinking 2. This is all one term, and this is all one term. Remember, terms are separated by pluses and minuses. So I ask that because we need to factor out the greatest common factor from those two terms. So what is the greatest common factor? Well, I'm going to look at the constant coefficients first. I see a 10 here and a 21 here, and an 18 here. I would say that 21 times 10 is 210, and that has a common factor of 6 with 18 here. Notice that this 6 that I'm referring to, this greatest common factor that includes a 6, I'm taking 2 out of this 10 and then 3 out of this 21 to form that 6. All right, what else do we have in our greatest common factor? Well, they both have this binomial 21x plus 8. One of them is raised to the 9th power, the other is raised to the 10th power. So let's say the greatest common factor is 6 times 21x plus 8 to the 9th power. That is our greatest common factor, GCF. And now, what remains on the inside of these big parentheses here? Well, 6 times 35 is what gives us 210. Remember, 210 is the product of these two constants. And we also have this binomial over here, 18x minus 5. Subtract. We've taken 9 out of the 10, 21x plus 8 out of this term, so that leaves 1 left over, 21x plus 8. And let's not forget the constant in front. We took 6 out from this 18, so that leaves us with 3 remaining. And let's not forget this denominator. I'm not really doing much with the denominator now, but I do insist we keep it along for the ride. We'll discuss more why I'm going to be picky about that in class. All right, but this is where our derivative stands now after the factoring. Okay, let's go ahead and distribute on the inside here. Let's distribute the terms on the inside of those big parentheses. So that should leave us with, I'll start with our greatest common factor here again. And 35 times 18 is 630. Is my mental math really that good, or did I use a calculator? I'm going to leave that as a mystery. 35 times 5 is 175. I would encourage you to practice your mental math as much as possible. I will admit there are some times where, practically speaking, I don't blame you for just grabbing a calculator. All right, and again, the denominator just hanging along for the ride here. And of course, as always, pause the video as you need to make sure that you're getting every step here. But let's proceed. Let's go ahead and simplify a little further the stuff inside the big parentheses there. So again, the greatest common factor here, as well as the denominator, are just coming along for the ride. And again, please do keep those at every step. I know it takes a few extra seconds to write them every time, but again, there are reasons for that we'll get into later. All right, inside the big parentheses here, if I combine 630x minus 63x, that is 567x minus 175, and then minus 24 combines to minus 199. And this is pretty much simplified. The only thing we should consider doing, if possible, is checking to see if there's any factor that can come out of 567x and 199. And I'm going to admit that may be a little bit much to ask you to do every time mentally. If we want to use a calculator shortcut, let's do it this way. So let's go to our calculator and say, what's 199 divided by 567? And we'll go, at least on these TI models, we'll go math, enter, enter, telling it to convert to a fraction. And the fact that it gave us a fraction of 199 over 567, those original numbers, it didn't reduce that fraction in any way. That tells us that that those two numbers do not have a common factor. All right, so I'm going to say this is our derivative fully simplified. And to find the critical numbers and or vertical asymptotes now, I'm going to go ahead and label this just for emphasis, reminding us that this is f prime. To find the critical numbers and or vertical asymptotes, we're going to set this derivative equal to 0 or undefined. We've presumably had some classroom discussion on why we might do that. Again, if you're not totally comfortable with that step, at least follow along and make sure you get all the algebra here. But in order to make that entire derivative equal to 0, that means that the numerator, one of the factors in the numerator must equal 0. So if I take this factor and set it equal to 0, that gives me x equals negative 8 over 21. I'm doing a little bit of the simple math in my head there. Of course, write it out if you feel more comfortable doing that. Let's set this factor equal to 0. That's going to give me x equals positive 199 over 567. And in order to make the derivative undefined, then we would need the denominator to equal 0. So if I set that factor equal to 0, we'll get x equals 5 over 18. From our earlier pre-calculus skills, we should already have a pretty good idea that that's going to lead to a vertical asymptote. All right, so again, these are our critical numbers and or vertical asymptotes. We'll have some discussion later on about whether all of these are technically considered critical numbers or not. We'll say that for another day. For right now, let's just move forward with these three, and I'll loosely call them all critical numbers. And let's turn to the calculator and check and see what these results tell us about the original function. So I'm going to graph not this derivative, but I'm going to enter the original function, the original f of x way up here. I'm going to enter that into the calculator. In fact, I've already done so. And I'm going to start with zoom decimal, zoom number 4. That's usually where I start. And we see in doing so that not much of a graph there. We see something that looks sort of like a vertical line segment going up to the x-axis, but can't really tell what's going on there. So here's where, to intelligently decide your window settings, I'm going to suggest we trace to those critical numbers. And I usually like to start with the messiest one, in this case, the 199 over 567. Let's trace to that critical number, 199 divided by 567. And look closely at that y value. You see what a large number that is? It says 5.5861, but then E11, that indicates that this is a number that starts with 5 and has 11 additional digits after it. This is a huge number, and we'd better set our window settings accordingly. So let's go ahead and go to window, and because I want to see above that 5 point whatever E11, I'm going to set my Y max to something that's well above that 5 point whatever E11. So let's say something like 9 followed by 11 zeros. And I can either type in 11 zeros or I can go second and then comma for that little E symbol and type in 11. And that's just a shortcut for adding 11 zeros after the 9. And I don't have to do this, but I generally like to make the Y min something comparable, something in the ballpark. So let's just say -2 followed by 11 zeros. And you can play with that as you want, kind of come up with your own style for that. But let's see what that looks like. All right, graph looks a lot better. We can now see the branch of the graph that's coming down over here. We're still not using the screen space real wisely. It looks like there's not much going on in the x direction, left of -2 or right of +1. So just to get a little better look, let's just go from -2 to +1 on the x. There we have a much better look at this graph. So let's again explore what's going on at those critical numbers. 199 over 567. And we see that is what appears to be a minimum of the graph. That is where the slope of the tangent line would be 0. Again, that should hopefully connect to some classroom conversations we've had. That's what the derivative is, right? The slope of a tangent line, and we expect the slope to be 0, either at minima or maxima typically. Let's go to another one of those critical numbers. Let's go to negative 8 over 21. That also appears like it could be a maximum. Admittedly, these window settings aren't the best for telling whether that point really truly is the maximum on this graph, but it seems plausible at least. A little more on that in a moment. How about the 5/18? Well, if we looked at the original function and rely on our earlier pre-calc skills, we should have anticipated that would be an asymptote. And sure enough, there is no y value there. If I just do 5/18 plus a tiny bit, like plus 0.01. If I go to the slightest bit to the right of the asymptote, that should ride up along this branch of the curve, and we should anticipate a really large y value. And sure enough, 1.657 E12, a really large number. And if I'd gone to 5/18, where I believe the asymptote is minus a tiny number, I'm going slightly left of the asymptote. That should go down along this branch of the curve, and I'm expecting a really negative number. And sure enough, I get one, negative 1.223 E12. So this is just confirming that there is an asymptote there, or at least supporting that claim. All right, now if I want to become a little more convinced that this maximum at negative 8 over 21 truly does look like a maximum, I could play with the window settings a little more if I want. Again, these really large window settings enabled us to see this minimum up here, but if I just want to check on this branch of the curve that I think has a maximum, I'm going to decrease those window settings. Based somewhat on experience, which you'll gain by playing around here. What if I just went to negative 200 and positive 100? Something much smaller. And now when I trace to negative 8 over 21, I'm a little more convinced that that is where the maximum is. All right, so play around with the calculator. You'll get much quicker at it as you get used to this process. Hope all that made sense. Time for you to try now. Oh, first of all, let me summarize here on the screen. Again, the findings that we just saw on the calculator. Now your turn to try. So here's your function g of x. Here's the derivative provided to you. Only a few weeks into AP Calculus, you'll be writing these derivatives on your own, but while we're still in pre-calculus, I'll provide them to you. So go ahead and pause the video at this point and find the critical numbers and our vertical asymptotes and check on a calculator. All right, I'm going to assume you've done this exercise, so let's just kind of briefly recap what you hopefully found. First things first, factor out the GCF, the greatest common factor. Let's go ahead and distribute those terms on the inside of the big bold parentheses, making sure not to commit any errors in the distribution, particularly distributing that negative sign. I don't think I pointed out in the example, but you're probably familiar with this stamp. Don't commit that crime. Go ahead and combine the terms inside the bold parentheses there. And again, if it's possible to factor that 80x plus 43 to factor something else out of that, we would, but doesn't look like those have a common factor. Here are the critical numbers and or asymptotes that result. And on the calculator, this is what you should have seen. And again, when you trace to the critical number at negative 43 over 80, that's this number here in decimal form, you get a really large number, 1.848 E9, and that guides you to setting some window settings intelligently. That might instruct you to set these window settings for your Y min and Y max, or at least something comparable. All right, hope all that made sense. We'll see you in the next video.